Imagine standing inside a factory where mountains of raw rock disappear into giant machines, and just a few hours later, they emerge as one of the most important materials ever created by humans. Nearly every bridge, skyscraper, highway, dam, and home around you depends on it. Yet almost nobody has seen how cement is actually made. The process is hotter than flowing lava, powerful enough to crush solid stone, and so precisely controlled that even tiny changes can affect the strength of entire buildings. What happens inside this incredible manufacturing journey is far more fascinating than most people realize. Everything begins at massive open-pit quarries, where the primary ingredient, limestone, is hidden beneath layers of earth. Enormous drilling rigs bore deep holes into the rock before carefully planned blasting breaks the limestone into manageable pieces. The explosions may look dramatic, but every blast is calculated to produce rocks of the right size while keeping the surrounding area safe. Giant wheel loaders and heavy-duty haul trucks, some capable of carrying hundreds of tons in a single trip, transport the freshly blasted rock toward the processing plant. But limestone alone isn't enough. Here's where things get really interesting. To create cement with the right chemical composition, manufacturers also add carefully measured amounts of clay or shale, along with smaller quantities of materials that naturally contain silica, alumina, and iron. These ingredients provide the essential elements needed for the reactions that will take place later inside the kiln. Before anything moves forward, samples are routinely analyzed to make sure the raw materials stay within the required chemical range. The enormous rocks now enter a primary crusher. This machine uses tremendous force to reduce boulders into much smaller pieces. Conveyor belts carry the crushed material through additional crushers and screens until it reaches a consistent size. Dust collection systems continuously capture fine particles, helping keep both the equipment and surrounding environment cleaner. What happens next might surprise you. Simply crushing the rocks isn't enough. The ingredients must be blended so thoroughly that every batch has nearly the same composition. Huge stacker machines arrange the crushed material into carefully formed stockpiles, while reclaimers slowly collect layers from different sections of the pile. This constant mixing helps reduce natural variations found in the quarry, creating a more uniform raw material before it enters the next stage. Now the journey moves into one of the most impressive parts of the factory. Massive raw mills grind the blended material into an incredibly fine powder known as raw meal. Inside these giant mills, heavy steel rollers, or large steel balls, crush and grind the rock until the particles become finer than ordinary flour. Powerful fans move the material through separators that return larger particles for additional grinding, while allowing only the finest powder to continue. This fine powder is stored inside towering blending silos. The real magic happens here. Air is introduced from the bottom of the silos, gently mixing the powder to keep its composition as consistent as possible. Continuous sampling and laboratory testing ensure the chemical balance remains within strict limits before the material is allowed to move into the heart of the entire operation. That heart is the rotary kiln, a gigantic steel cylinder lined with heat-resistant materials and slowly rotating day and night. Stretching for dozens of meters, it becomes one of the hottest places in any manufacturing facility. Before entering the kiln itself, the raw meal usually passes through a preheater, where hot gases rising from the kiln warm the material. Many modern plants also use a pre-calciner, where much of the limestone begins releasing carbon dioxide before reaching the main burning zone. This improves efficiency and reduces the amount of fuel needed. As the material slowly travels deeper inside the rotating kiln, temperatures continue climbing. Moisture disappears first. Then, powerful chemical reactions begin transforming the minerals. Finally, near the hottest section, temperatures approach around 1,450 degrees Celsius, hot enough to partially melt the material. At this point, entirely new minerals form, creating small, dark gray nodules known as clinker. This is the step most people never get to see, and it's the moment where ordinary rock is permanently transformed into the foundation of modern construction. Watching glowing clinker emerge from the kiln is an unforgettable sight. But surprisingly, the process isn't finished yet. The red-hot clinker immediately enters powerful coolers, where large volumes of air rapidly reduce its temperature. Fast cooling is important because it helps preserve the mineral structure created inside the kiln, while also recovering heat that can be reused elsewhere in the process, improving overall energy efficiency. Once cooled, the clinker is transported to storage. At first glance, it looks like nothing more than small gray stones. Yet these seemingly ordinary nodules contain all the chemistry needed to become cement. The next stage unlocks that potential. The clinker now enters another grinding system, but this time one additional ingredient makes all the difference. A small amount of gypsum is added during grinding. Without it, cement would harden far too quickly when mixed with water, making it almost impossible to work with. Depending on the type of cement being produced, manufacturers may also add other approved supplementary cementitious materials, such as ground granulated blast furnace slag, fly ash where available and permitted, or finely ground limestone. These materials can improve certain properties and reduce the amount of clinker required. Inside massive finish mills, everything is ground together into the ultra-fine powder recognized around the world as cement. The grinding process is carefully monitored because particle size directly affects how the cement performs. Too coarse, and it may develop strength more slowly. Too fine, and it may require more energy to produce, or change how it behaves during use. Before any cement leaves the factory, rigorous quality control begins. Laboratory technicians test samples throughout production, checking chemical composition, fineness, setting time, and compressive strength according to established industry standards. Modern control rooms filled with computer screens continuously monitor temperatures, material flow, fuel consumption, and countless other operating conditions. Skilled engineers and operators adjust the process whenever needed to maintain consistent quality. But here's something many people never think about. Cement isn't concrete. Cement is actually just the binding ingredient. When construction crews combine cement with water, sand, gravel, or crushed stone, a chemical reaction begins that hardens the mixture into concrete, the material used to build everything from sidewalks to skyscrapers. After passing every quality check, the finished cement is stored in enormous silos. From there, automated systems either load it directly into bulk tanker trucks for large construction projects, or send it through high-speed packing machines. These machines accurately fill paper bags, seal them, and place them onto pallets, where robotic equipment prepares them for shipping. Forklifts move the finished pallets into warehouses before trucks distribute the product to construction sites, hardware stores, and infrastructure projects across entire regions. It's incredible to think that this journey started with nothing more than layers of limestone buried underground. Through careful engineering, massive industrial machinery, extreme heat, precise chemistry, and constant quality control, Those ordinary rocks have become the material that helps shape cities, connect countries, and support billions of people every single day. The next time you walk across a bridge, enter a high-rise building, or drive down a highway, you'll know the remarkable journey hidden inside every structure. If you enjoyed exploring how cement is made, don't forget to like this video, share your thoughts in the comments, and subscribe for more fascinating factory tours and manufacturing documentaries that reveal the incredible processes behind the products we use every day.